Hey Vsauce, Cameron here, and today we're going to be discussing blackbody radiation. But what is blackbody radiation, and what is a black body? Well, in order to talk about blackbody radiation, we first need to talk about thermodynamics. Now, if I was to heat up a piece of metal, and then stop heating it up, it will slowly begin to cool back down. This is because nature doesn't like things to be unbalanced. So its temperature will slowly begin to equalize with the room. When it reaches this point of equalization, it is said to be in thermal equilibrium. But where did all this heat energy go? Some of it may have been transferred to the air and surrounding surfaces, but most of it was actually radiated away as light or electromagnetic waves. This is called radiative cooling. Now this might be hard to visualize with a piece of metal heated to only 100 or so degrees Celsius. But what if I heated this piece of metal to 3000 Kelvin? Well, as it heats up, it would begin to glow red hot. This is where our heat energy is leaving. It's leaving as visible light and infrared radiation. Now, if we continue heating up this metal, it will begin to glow orange, then yellow, and then eventually white. So there must be a relationship between the temperature of the metal and the wavelengths of light it produces. And there is. This graph shows the blackbody spectrum. Note that as the temperature increases, the peak intensity increases and occurs at a lower wavelength. Also note that to the right of the peak in the infrared range, the graph is a smooth curve, and to the left of the peak in the ultraviolet range, the graph has a fairly steep drop. Now this relationship between temperature, wavelength, and intensity can be seen in many things all around us. For example, a filament light bulb will start off glowing red at a low intensity and with a small amount of current heating up the filament. But as the current increases, the bulb glows orange, then yellow, then white, all while the intensity of the bulb is also increasing. The sun also has a very high temperature. This explains why it glows white with such intensity. Now the question you're probably asking is that if the peak energy for an object like the sun occurs in the blue-green spectrum, why is the light we see orangish-white? Good question. Remember from the graph that not only is the sun radiating blue-green light, but also yellow, orange, red, infrared, and even some purple. Even though the peak is blue-green, our eyes average all the colors together and we see an orangish-white. What's important to realize is that this relationship occurs independently of the material, whether it's the sun, a light bulb, hot coals, or even a human. The same relation exists. But we still haven't answered the question, what is a black body? The term black body was first used by Gustav Kirchhoff in 1860 to explain an object that emits and absorbs electromagnetic radiation of all wavelengths. Well, in that case, something like the burner on an electric stove would be a black body, right? Well, yes, kind of. It will emit electromagnetic radiation of all wavelengths, granted in significant amounts in the UV spectrum. A perfect blackbody would be a perfect absorber and emitter of radiation. Since you can see a stove burner when it's turned off, it isn't a perfect black body because it's reflecting some of the light, making it visible. It isn't emitting the light to make it visible. A perfect black body just isn't possible since everything reflects some light. Something like the sun, however, gets very close, as almost all the light it produces is a result of fusion. Almost none is reflected from other sources, and it emits in all ranges of the spectrum. So in conclusion, blackbody radiation explains why things glow when they heat up, why the peak wavelength emitted gets shorter as they heat up, and why the intensity of the radiation increases as they heat up. The one thing it doesn't explain is why the graph would dip down in the ultraviolet range. But the ultraviolet catastrophe and Planck's constant are whole subjects on their own. So there we go. We know what a black body is, and we know how it radiates energy. Blackbody radiation. Thanks for watching.